Okay, in this video I'm going to show you some examples on how we can use the concept of derivatives. So these are basic problems that usually being asked in an assessment or in a test. So the first one is find the value of dy over dx. That means the derivative at x equals to if y is equal to 3x to the 4 minus 4x squared plus 5x plus 8. So basically, the question is about getting the derivative and then find the value of that derivative at x equals 2. So all we have to do is to differentiate the given function. So if y is equal to 3x to the 4 minus 4x squared plus 5x plus 8, dy over dx is equal to 12x cubed. That's 4 times 3, that's 12. Then x to the 4 minus 1, that's 3. And then minus 8x plus 5. So at x equals 2, dy over dx is equal to 12 times 2 cubed minus 8 times 2 n plus 5. 12, this is times 8 minus 16 plus 5. This is equal to 96 minus 16 plus 5. This is equal to 80 plus 5. Therefore, this is equal to 85. So whenever you are asked to find the derivative at a particular value, so simply get the derivative and use that value of x. Substitute it to the derivative, and that's it. Okay. Another type of problem that you might encounter involving derivatives is finding the slope of the tangent and the normal line to the curve or to the given curve at a value of x. So basically the idea is that to get the slope, you have to get the value or the derivative, and then just find the derivative at the given value of x. So if y is equal to 3x squared minus 8x plus 9, then dy dx is equal to 6x minus 8. So the slope at a given value is the derivative at that value. So at x equals 2, so it says you find the slope at x equals 2. So at x equals 2, dy over dx is 6 times 2 minus 8, which is 12 minus 8 equals 4. So the slope of the line tangent to the curve at x equals 2 is 4. Now to find the slope of the normal, so take note that the normal line is the line perpendicular to the tangent line. So if the slope of the tangent line is 4, the slope of the normal line is the negative reciprocal of the slope of the tangent. So this should be negative 1 over 4. Usually this kind of problem is an introductory problem to finding the equation. So usually you have to find the equation of the tangent and the normal line. But in this case, all we wanted to do is just to find the slope. So that means get the derivative and then find the value of the derivative at a given number, and that's it. The slope of the normal line will come from the slope of the tangent line because the normal line is perpendicular to the tangent line. Okay? So some problems would also ask for higher derivatives. So it's either you want to take the second derivative, you want to take the third derivative, you want to take the fourth derivative of a function. You just have to be familiar with the notations. So the symbol f then this symbol means the second derivative. And there's another symbol for second derivative. You can use d squared y over dx squared. That's also the second derivative. Or they just say find the second derivative of the given function. So second derivative is just the derivative of the first derivative. So you keep on differentiating the function depending on how many times you want it. So it says second, so you have to differentiate it twice. So if the function is given as so you have f of x is equal to 4x to the 5 minus 8x to the 4 plus 3x cubed minus 5x squared minus 12x plus 3. So we have to get the first derivative before we can go to the second derivative. So this is 20x to the 4 minus 32x cubed plus 9x squared minus 10x minus 12. Then after that, you can now get the second derivative. So the same procedure. So this will be 80x cubed minus, so this is 96x squared plus 18x minus 10. And that's the second derivative. If they ask you for the third derivative, then just get the derivative of the second derivative. Okay, so it depends on how many times you want to get the derivative. Okay, so those are the examples of problems that you might encounter which involve derivatives. Okay, so that's it.